This is question 41 from the GATE 2018 EE paper, in which we are given an NPN-BJT based circuit and we are asked to find out what the Thevenin equivalent resistance is as seen from the AB terminals. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. So in this question, we need to first find the bias point of this circuit, that is, what is the emitter current, base and collector currents for these values of resistances and bias voltages. The idea is that we will write an voltage equation for this loop, knowing that this is 0.7, right? 0.7 is the diode drop, so it is 10 volt minus IB into 10K, that's the voltage drop there, minus 0.7 minus IE into 1K is equal to 0, and IE can be written as IB plus IC. Since beta is equal to 100, IC is 100 IB, right? Substituting all of this into the first equation, we get this, right? This solves to IB being 10 by 101 milliamps. Now this is the small signal equivalent of the circuit, where the DC sources are nulled, right, and you replace the transistor by its small signal model. We already know beta, we only need to know what R pi is. R pi is given by VT by IB. This is 0.288 kilo ohms. Now RTH is V test by I test. I have given a 1 volt test, so it's simply 1 by the input current. Now I can be given as minus of this plus this by the KCL, right? This is equal to minus 1 by 1K, because the voltage across here is 1 volt, that's applied, right? And this is IB plus beta IB, that is base current plus collector current. So therefore we get I as minus of IB plus beta IB minus 1K, which is plus 1K. Finally, rearranging this, we will get that IB is equal to minus 1 by R pi plus 10K. Next, IB will be equal to, so the voltage across here is again 1 volt by this supply, right? So therefore the value of IB is the voltage. If IB is taken in this direction, you have to take the voltage like that, so it's minus 1 divided by the total resistance, that is R pi plus 10K, which is minus 1 by 10.288 kilo ohms. Substituting this value of IB in the equation above, you will get this expression for I, right? And you will find that I is equal to 10.972 milliamps. RTH is 1 by I, which is 91.1 ohms. Thus the answer to this question is 91.1 ohms.